Hi, I'm Alex and I'm a H1 chemistry student. Today we're going to be doing a question 2, which is your organic experiments question. And we'll fly straight into this one. It's a nice easy one, so we'll fly straight into it and I'll go through the most important bits of this question. Now, so this question has 3 parts, part A, B and C. And in this case, each of the 3 parts are on a different experiment. So the first part A, will be an experiment to the purification of benzoic acid. Again, nice question. Really this is quite a wordy question, so there's no calculations involved here at all, but nice easy marks to pick up. Just jot down the information, you can fly through it. And then part B is all about aldehydes, so in this case it's ethanal. It's important that you identify that as the AL ending, so that you know that it's going to be aldehydes we're dealing with. And it just really is asking about how we identify the aldehyde and the tests which we can do on it. And then finally, part C is about the preparation of soap, which is another experiment that you would have done. And again, just about the reaction and all like that, all wordy in this question 2. So nice easy marks to pick up, no maths, nothing you can really go too far astray. So we'll dive straight into part A and we'll get started with that. So now, part AI, they're asking us about why water will be a suitable solvent for the benzoic acid recrystallization. So we know from doing the experiment that benzoic acid, we want the crystals in this since the recrystallization. And we know that benzoic acid has very low solubility in cold water. So that's a very good answer for this question. And next part, you could also say kind of the opposite, where you could say that benzoic acid has high solubility in hot water. So either or would work because both hot and cold solutions would be needed for this experiment. So either or would work for this question. And then part II, explain the purpose of the first hot filtration step. So this is to remove insoluble impurities. So that's the likes of any of your solids or anything that won't dissolve in the solution. You can remove them by doing a hot filtration because everything that is soluble will definitely be dissolved in the solution when it's hot. So the marking for this question, you'll pick up 4 marks for explaining why water is a good solvent for this experiment, and you'll receive an additional 4 marks for identifying that you have to remove the insoluble impurities. So that's a really nice 8 marks to pick up for the first step of this question. So dive into the next question. And now part 3, part III, they're asking us why fluted filter paper is used in this experiment, in the hot filtration step. So they're looking just for one answer out of 2 here. So it gives an increased surface area, because if you imagine if the filter paper was just flat, if it wasn't folded at all, there'd be way less surface area than the fluted one, which is folded into small creases. And that also provides it with a faster filtration. So both help the efficiency of the experiment, and it just makes it go a lot quicker. And you receive better results from doing it this way also. And then for this question, for either of these answers, and there's also a few more accepted, so you could say that keeps the solution warm, it avoids benzoic acid coming out of the solution, and also increases the yield. So for any of those answers, you will have received another 4 marks. So part 4 of this question, of part A, with the benzoic acid, they're asking us why the second filtration is only carried out after a sufficient period of cooling. So this is to maximize the yield. So when you're recrystallizing it, of course, there's going to be more dissolved in the solution when there's at higher temperatures. So there's going to be more of those benzoic acid crystals in solution and not in their crystal form at the higher temperatures. So once you bring it down to those lower temperatures, you get as much benzoic acid out of it as possible. So it's going to maximize the amount of benzoic acid you get out. So now a nice easy 3 marks picked up for this question, and then we'll fly now into part 5 of this. Now, so part 5, they're looking for what observation would the student make that shows that the recrystallized benzoic acid was pure. It's important there that you pay attention to that they say pure, because if they're saying impure or whatever else they might say, it could be a different answer. But in this case, they're looking for a melting point range that is very narrow. So if you imagine if the benzoic acid is pure and the crystals are all just benzoic acid, all the substances are going to have a very similar melting point. Well, it should be nearly the same. There's always going to be small impurities in there, but the benzoic acid will be nearly pure, or pure in this case, so it'll be a very small range. Whereas if there was loads of different compounds in there, and if you had a bit of salt and you had a bit of whatever else, a bit of water in there, it would all start melting at different temperatures and at different points. So the range would be a lot wider. So that's how we tell with crystals like this how pure the substance is. So you want a very narrow range, and that will tell you that it's a pure substance. So then the marking for this question, you'll receive 3 marks for mentioning the melting point, and then you'll receive an additional 2 marks for mentioning that the range was narrow, or that it was sharp, or that it was close to the correct value. So that's a nice, easy 5 marks to pick up at the end of this question. So we'll run back to the main question now, and we'll have a look at where we're at. So now we have part 4 and part 5 done. So that's our 20 marks total for part A. Really nice, quick marks to pick up, just jotting down a few words here and there. We'll fly on now to part B, which is about our aldehydes and the tests for the aldehydes. And in this case, as we said earlier, it's ethanal, which is very important that you recognize by the naming what functional group we'll be using. So we'll fly into part I, which is identifying the reagents used. So we'll get into that now. So now in part I, they're asking us to identify the reagents used that a student could use to show that ethanal is easily oxidized. And we know that all our aldehydes are easily oxidized. So here I've written down acidified potassium permanganate, but you would have also gotten away with any of your other strong oxidizing agents or other oxidizing agents. Any of them would have been accepted. So you could have also tested for this using a feeding solution of parts A and B. And you could have also used a Tollens reagent. So any of these would have been accepted in this case. But it's important that for part I, which you'll see in a minute, that your answers match up with the one that you picked. So then for identifying your oxidizing agent, the reagent used that the student could have used to show that ethanal is easily oxidized, you'll receive 3 marks. So 3 marks here, nice and easy. I did just want to mention here as well, it's very important that you say acidified KMNO4, because if you just wrote down KMNO4, you would not have gotten any marks for this question. It's very important that you say acidified, or else you wouldn't have got any marks for this question. So we'll fly on now to the next part. So now just for part 2 of this question, they're asking us to state the colour change observed for the reagents that we used. So in our case, we said that we used acidified potassium permanganate. So the colour change will be from a pink, purple colour to colourless. Whereas then if you had used the feeding solution, the parts A and B, it would be from a blue colour to a red. And for Tollens, it would be from colourless to silver. So it doesn't really matter which one you picked. They all are valuable answers and they're all correct. It's just important that your colour change matches the solution or the reagent you identified in part I. And then for this guy, you'll receive 3 marks for identifying the pink/purple colour, and then 3 marks again for identifying the colourless. So it's important that you get both of these and that you don't just put down one. And again, that you match it with the reagent you identified in part I. So now going back to the main question, or on part B, I've done part 1 and part 2. So we've identified the reagent and stated the colour change. So now we're going to be looking for the organic substance produced in this test. And then they're going to look for an equation for the reduction of the inorganic reagent used in this test. So that inorganic reagent is the potassium permanganate in our case, but it would have been from the Tollens or the Feelings, whichever reagent you'd like to use in your case. So we'll fly into those questions and I'll delve into what's involved in that. So now part 3 of this question, they're asking us to identify the organic substance produced in this test. And this case is going to be ethanoic acid. So we know that since we're adding an oxygen to the ethanal, and we're given ethanal in this case, so we know it's a 2-carbon since it's the ethanal, and we know it's an aldehyde since the ending with the ANAL. So when you oxidize an aldehyde, you're always going to get carboxylic acid, and that's just one of those reactions you learn off. And since we know it's ethanal, it's going to have that ETH at the start, which identifies any of the 2-carbon organic substances. So it has to be ethanoic acid in this case. So for identifying ethanoic acid in this case, you'll receive 3 marks for this question. Okay, we'll fly on now to part 4 of this question and the last part of part B. So now the final part of part B, which is part 4. They're looking for the half equation of the reduction of the inorganic reagent used in this test. So as we said earlier, the inorganic reagent we used in this test was acidified potassium permanganate. So we know that our half equation is going to involve the potassium permanganate in some degree. And since it's a reduction, we know the oxidation number will be going down. So it'll be decreasing from the start to the end of the reaction. So in this case, we can see from the colour change, it goes from a purple to a colourless. So this is really the part of the question where we're pulling all the information together about this test and about everything we know about this reaction all into this final part. So we know that we go from Mn7 plus to Mn2 plus. That's the reduction that happens to the inorganic reagent. And of course, this will change depending on what reagent you used for the test in the first place. We used potassium permanganate, but say if you used the Fehlings or the Tollens, they would have been different equations, different half equations. So for example, the Fehlings would have been copper that we're using, not the manganese like we used. So it would have been a copper 2 plus to 1 plus. And again, the Tollens solution, that would have been Ag plus to Ag neutral. So there would have been no charge. So that's the other two cases, but potassium permanganate we use in our case. So we got the 7 plus to 2 plus. And then for writing this half equation of the reduction of the manganese, in this case for our potassium permanganate, you received 3 marks. And that's the final part to part B, part 4. So now we have question B done, part B done. So we did part 3 and part 4, and we got our 15 marks. Nice easy 15 marks to pick up. Again, just a few words here and there. So we'll fly on now to part C of this question, the last part, and it's going to be about the preparation of soap, where we'll get another 15 marks and this question. So we'll go into part I, where they're looking for the reactants used for the preparation of soap. So there's going to be 2 reactants that we need for the preparation of soap. It's going to be something like an oil, a lard, or a fat, and obviously you don't have to put in the 3 of them. I just showed 3 examples here. They also accepted triglyceride or glyceryl tristearate as well. Stearin, tristearin, any of the above. Really anything fatty, oily, any of those substances you can use to make soap with. But you also needed a salt as well. So in this case, sodium hydroxide, or they also accepted potassium hydroxide in this case. So you need both of these for the preparation of soap. So they're the 2 reactants you need. And then for getting your fat, your lard, your oil, any of the above, as I mentioned earlier, you'll receive 3 marks. And again, you'll receive another 3 marks for your sodium hydroxide or your potassium hydroxide. So then in part 2 of this question, they're asking us to identify the solvent used for the preparation of soap. And in this case, it's ethanol. And we know it's ethanol because since we're dealing with fats, are nonpolar, which is the fats, though all the nonpolar substances, they dilute a whole lot better, or they dissolve a whole lot better in ethanol as opposed to water. So ethanol is the correct answer for this step, and you will receive an additional 3 marks for ethanol. And now we're nearly there, onto the final part of this question. So now the final part of the whole question and the final part of part C, which is about our soap preparation, will be to name and draw the co-product formed when soap is prepared in this way. So asking us to name the product, which as we've written down here, propane 1,2,3-triol. So that's the name of it, and I'll show you how to draw it now based on the name. So they're also asking us to draw the molecular structure of this co-product, including all atoms and bonds. So they're not just asking us to draw the line diagram or anything like that. They're looking for the full Lewis structure that shows all the molecular structure and all the atoms and all the bonds included. So I'll show you now how to draw that out. So now to drawing out the molecular formula for this, we're going to start with the name, since we already know that. So we have a propane, so it's the AN. So we know it's going to be an alkane group. So it's just going to be single bonded carbons, single bonded to each other. And we know it, since it's the prop, P-R-O-P, that it's going to be 3. So we'll draw out our 3 single bonded carbons. So that's our propane part of this. And then we know it's 1,2,3-triol. So that OL part tells us that there's going to be the alcohol groups on carbons 1, 2, and 3. And in this case, since it's bonded, we only have 3 carbons and there's a group on each of them. We can just throw an alcohol group on each of them. And we know that the alcohol group is the OH group. So it's going to be a OH on each of these carbons. Throw them in here. And that's all the information we're given. So we know it's an alkane, so they must be 4 bonded, and there's no double bonds, no triple bonds, no nothing like that. So we just fill the rest of the bonds in with hydrogens. H, H. This guy only needs 1 H because it already has 4 bonds. So it has the 2 carbon bonds and the alcohol group bond. And then the 2 side ones need another 2 hydrogens. So then just make sure, go around, make sure that all your hydrogens have 1 bond, all your oxygens have 2 bonds, and all your carbons have 4 bonds. And then once that's done, you're done. That's your full molecular structure, drawn out, all the atoms included, and everything like that. So then, just for identifying the name, you would have received 3 marks. And for drawing out the full structure, including all the atoms, all the bonds and everything, you would receive an additional 3 marks. On the naming, we have propane 1,2,3-ol here. You would have gotten away this year with glycerol as well, and they also accepted glycerin and glycerine as well this year. So any of them would have been accepted and you would have got full marks for any of those answers. So that's the last part of this question. We'll go back to the full question and see where we're at and tick off what we've done. So now we're just finished part C. So we've identified the reactants used in the preparation of soap. We identified the solvent used in the preparation of soap, and then it's mislabeled here, it says II, but it's actually part 3. We showed the molecular formula, the molecular structure, with all the bonds and all the atoms included, and we named the substance. So that's our full 15 marks for this question, and that's the end of this organic question. So I hope you enjoyed this video, and I hope it was helpful. Thanks so much.